Imagine you are designing a secure building. Your virtual network is the building, and the network security group acts like a security guard at each entrance and room. It checks every visitor and decides whether to let them in or not. That's exactly how NSGs work in Azure. A network security group is your first line of defense to control network traffic to and from Azure resources. You can assign an NSG to either a subnet or a network interface card and then define security rules within it that act as checkpoints for incoming and outgoing traffic. Subnet level NSG controls traffic to all resources within the subnet, perfect for applying blanket policies like a demilitarized zone. Network interface level offers granular control at the individual virtual machine level. You can assign one NSG per subnet and one NSG per NIC. If both are used, the effective rules are a combination of both. Security rules in a network security group act as traffic filters that help you control the flow of data to and from your Azure resources. When you create these rules, you're essentially defining who can talk to your resources, on what ports, using which protocols, and whether that traffic should be allowed or denied. You set the source of the traffic, which could be any address, a specific IP range, your own IP, a service tag, or even an application security group. You also decide which source ports the rule applies to and where the traffic is heading. Again, using IP ranges, service tags, or application groups as the destination. You can choose to filter based on protocols like TCP, UDP, or ICMP, or just apply the rule to all traffic. The action you define will either allow or deny the traffic. Each rule also has a priority, ranging from 100 to 4096, where lower numbers have higher precedence. Lastly, you decide if the rule applies to inbound or outbound traffic. It's important to remember that Azure processes these rules in order of priority. Once a rule matches the traffic, no other rules are evaluated. So the order in which you configure them matters significantly. Let's say you have two subnets: Web subnet for public-facing VMs, DB subnet for databases. You can apply an SG to Web subnet that allows only HTTP/HTTPS traffic. Apply another NSG to DB subnet that only allows traffic from the web subnet's IP range on port 1433 for SQL. This way, you've isolated your database and minimized the attack surface. When you create a network security group in Azure, you are automatically provided with a set of default rules that form the baseline for network traffic control. You can't delete these rules, but you can absolutely override them when needed. For inbound traffic, Azure allows communication from within the virtual network through the Allow VNet Inbound rule, and it also permits health probes from Azure Load Balancer using the Allow Azure Load Balancer Inbound rule. Everything else trying to come in is blocked by the Deny All Inbound rule. On the outbound side, Azure enables traffic within the virtual network using Allow VNet Outbound and also allows connections to the internet via Allow Internet Outbound. Any other outbound traffic is blocked by Deny All Outbound. If these defaults don't align with your security needs, you can create custom rules with a lower priority number. This gives your rule higher precedence and lets you take control of traffic exactly the way you want. So, what's your key takeaway? Azure gives you a solid security baseline with default rules in every NSG, but you're not stuck with them. While you can't delete these rules, you can override them by creating your own custom rules with a lower priority number. This gives you full control to tailor network access exactly the way your application or environment needs it, safely and securely.